Have you ever stopped and wondered if the world you see is, well, the only one that exists? What if I told you that all around us, right now, there's a reality buzzing with secret messages and hidden colors, a world completely invisible to our eyes? Well, get ready, because that's exactly the world we're diving into today. We're going to see reality through the eyes of a bee.
Just take a look at this. To us, a red rose is this classic symbol of beauty, right? But to a bee, it's just a black hole, a void in their vision. Why? Because bees literally can't see the color red. And this single stark difference is our first clue that a bee's world isn't just a little different from ours, it operates on a completely different level of reality.
All right, so let's pull back that curtain on this unseen sensory universe. We're about to explore how bees experience the very same physical space we do, but through a set of senses so alien it creates an entirely separate reality.
Look, we're not just talking about a slightly tweaked version of our world. A bee's reality is built on totally different rules of light and motion. As the source material puts it so well, it's a vibrant tapestry of colors, patterns, and polarized light that humans can barely imagine. We are missing out on so much.
So how is any of this even possible? Well, to get it, we have to look at the incredible biological hardware they're working with. It all starts with the amazing structure of their eyes.
5,000. Just let that number sink in. That's roughly how many tiny individual lenses, called ommatidia, are packed into each of a bee's two compound eyes. You can think of each one as a single pixel, capturing its own tiny piece of the bigger picture. Now, this whole setup is a fantastic example of an evolutionary trade-off. By building an image from thousands of tiny little parts, bees totally sacrifice the sharp, high-resolution detail that we're used to. But, and this is a big but, what they get in return is an almost supernatural ability to detect motion. Anything that moves, bam, it's instantly on their radar.
But where their vision truly goes off the rails from ours is in color. Our eyes, as you probably know, are built on three primary colors: red, green, and blue. Bees, on the other hand, just swapped red out entirely, and in its place, they gain the ability to see a color that is completely, utterly invisible to us: ultraviolet.
And this right here is where their world truly becomes something out of science fiction. For a bee, the landscape is literally painted in UV light, which means it's filled with these glowing signals and radiant patterns that guide their every move.
But hold on, because seeing in ultraviolet is just the beginning. A bee's vision comes with two more abilities that are, frankly, nothing short of superpowers: an incredible processing speed and a secret, built-in compass.
Okay, think about it like this. A really smooth movie or a high-end video game runs at about 60 frames per second for our brains. A bee, it processes visual information at over 200 frames per second. They are literally seeing the world in high speed, more than 3 times faster than we do.
And that's not just some cool party trick. This high-speed vision is an absolutely critical survival tool. It's what allows them to zip through a dense forest without crashing or land perfectly on a flower that's swaying in the wind. To a bee, our world looks like it's in slow motion. Seriously. So, we've got UV vision and super speed processing. You'd think that's enough, right? Nope. Bees have another trick up their sleeve. They can see a property of light that is completely hidden from us. It's polarization.
So what is this stuff? Well, sunlight scatters in our atmosphere in these very predictable patterns, and bees can actually see these patterns all across the sky. It acts like a giant celestial compass, letting them know exactly where the sun is, even if it's a totally overcast day. It's their own built-in GPS for getting back to the hive. So, you gotta ask, why? Why did this incredibly complex alien vision system even evolve? Well, the answer is all part of one of nature's most beautiful and intricate partnerships: the secret communication between bees and flowers. When we look at a field of sunflowers, we see this vast, gorgeous, but pretty uniform sea of yellow. It's beautiful, but visually, it's pretty straightforward. But to a bee, that exact same flower is a completely different object. It's a beacon. It's got a dark center and bright outer petals that form a glowing bullseye, all painted in these stunning patterns of ultraviolet light.
These hidden markings are called nectar guides, and they are, for all intents and purposes, a secret language written in UV. They act like glowing landing strips on an aircraft carrier, basically screaming, "Hey, over here, the good stuff is right in the middle."
And this wasn't some happy accident. Oh no, this is a sensory collaboration that has been perfected over 100 million years. As bees evolve the eyes to see UV light, flowers evolve the pigments and patterns to attract them. It's one of the most successful partnerships in the history of life.
So, what can we take away from all of this? I mean, besides the fact that bees are even cooler than we thought. Well, studying this alien perspective isn't just a fun thought experiment. It has real-world applications and some pretty profound implications for how we see, well, everything.
You've got engineers right now who are actively mimicking the principles of the bee's compound eye to create amazing new tech. We're talking about everything from ultra-wide-angle cameras to motion detectors and navigation systems for drones that can fly through really complex spaces. We are literally learning from this tiny insect's genius.
But maybe the most profound lesson here is a philosophical one, and it's captured by this single, powerful biological concept, Umwelt. It's the idea that every species lives in its own unique sensory world. The reality a bat perceives through sound is different from the bee's world of UV light, which is different from ours. Each one is its own valid, self-contained slice of reality.
And this leads to a pretty humbling conclusion. Our reality isn't the only real one. It's just the human version. The bee's reality, which is built from motion, polarization, and ultraviolet light, is every bit as valid. It's just a different, yet complete translation of the same physical world.
It's a humbling and kind of exciting idea, isn't it? It forces us to accept that the universe we see is only a fraction of what truly exists. Our perception is like a keyhole, not a giant window. The universe is infinitely more complex than our senses can ever show us.
And that leaves us with this final, fascinating question to ponder. If a tiny bee experiences a world so radically different from our own, what other realities are all around us, right now, just waiting to be discovered, hiding in plain sight?